Welcome to my project bazaar.com. Let me discuss about the process lossless predictive coding for images with the Bayesian treatment. In this process, adaptive predictor has been used lossless predictive coding of images, and then we have to most of existing lossless predictive coding techniques mainly focus on suitability of prediction model for training set with underlying assumption of local consistency, which may not hold well on object boundaries and cause large predictive error. In this paper, we propose a novel approach based on assumption that local consistency and Bayesian resistance exist simultaneously in natural images. We derive a family of linear models and design a new algorithm to automatically select one suitable model for prediction. From the Bayesian perspective, the model with maximum posterior probability is considered at the best. Two types of model evidence are included in our algorithm. One is traditional training evidence, which represents the model's suitability for current pixel under the assumption of local consistency. The other is target evidence, which is proposed to express a preference for different model from the prospective patch redundancy. This is very efficient, reduce the complexity of residual entropy of the input image from using the process of predictive coding. This is shown the fusion of training evidence and target evidence jointly exploits the benefits of local consistency and patch redundancy. As a result, our proposal is more suitable for natural images with textures and object boundaries. Comprehensive experiments demonstrate that proposed predictor achieve a higher efficiency compared with the state of lossless predictors. And then we have to see the another process is like that, the flow chart. The flow chart is this is the flow chart of our process, the lossless prediction. This first of all we have to take the input images. The input images is as a natural images of our process. We have to predict the input process to using the Bayesian treatment. The Bayesian treatment is efficient method to predict the output from the compression process. We have to take the training and the target samples from the input image to segmentation, basic segmentation of many pixels in the process. We have to target evidence extracted from the input image to very efficiently. The process is nothing but the Bayesian classifier processes to be obtained the training and the target samples to simultaneously. They very help to predict the output images from the batch conversion of a input image. From this process of segmentation, converted batches are take as reference batches from the train and the test and also build the target values for the prediction. After the Bayesian classification is to retrieve the original image for the further process. The final process technique we have to use a adaptive run length encoding like a compression and a decompression. This is important model to reduce the complexity in the input image. To compress the input image from using this calculation from we have to compress the image and to reduce at all probability of drawbacks and the prediction in this existing system. Adaptive run length encoding process is used for compress the input image on the process of Bayesian prediction for input image, and the final process of our flow chart is like that, the decompression. The decompression is nothing but the decompression process to the final process of our retrieving the output image of process of comparison as adaptive length encoding process. The reverse process of encoding from the decompress the process of retrieval in the decompression on the prediction. This is efficient process to retrieve the output image for this process. This is the MATLAB main window. In that main window we have to concentrate on four things: current folder, command window, workspace, and then command history. The command history is nothing but working onwards, and the process in command window is to be stored in our command history. And then command window is nothing but whenever you run any coding, it executes parts visually in the command window. And then workspace stores the values and variables of using the data types and values and variables and the coding. Current folder is to be load our important files and the executed files in our process. Then in this current folder we have to select the GUI main.m file, right click and click run. We have to window for our process, the first visual process. This is the first visual process of our lossless predictive coding for images with Bayesian treatment. In this process we have to take the input images as natural images. In this natural images we have to take the third image, click open. The input image to be viewed in the first display. This is the representation of input image taking of our process. The next process we have to converting the batches using the segmentation for input image. After clicking the batch conversion, we have to take the segmented output of our process. The segmented output helps to us taking the training and the target samples of our process. After clicking the Bayesian classification, we have to retrieve the original image from the converted batches of our process. After clicking next, we have to go in the final window of our process. In this final window, we have to take the process technique like adaptive run length encoding to be used. After clicking the compression button, we have to display for compression output is to be viewed, and then the value is to be obtained the table. Then we have to save the compressed image, click save, and this is the values for compressed output of our process. This is the compressed output. Then we have to click the decompression. This decompression output to be saved. This is the decompressed output values of our process. The RGB values to be displayed separately of our process. This is the output of decompressed image. Then click the performance. After clicking the performance, we do two performance metrics to be calculated. The residual entropy is like 0.69, and also the compression ratio is 33.39. These two values is important performance metrics as the compression process of our lossless prediction coding for images, natural images as like. Now we have to conclude our process. An adaptive run length encoding is used for the compression problem. Different from traditional algorithm, we investigate target samples and derive the new type of model evidence called target evidence. The novel evidence is combined with the traditional training evidence to jointly exploit the benefits of local consistency and batch redundancy. The proposed algorithm outperforms the state-of-art algorithm in terms of objective and subjective evaluation to reduce the complexity of input image from comparison. A powerful algorithm like adaptive run length encoding in our paper. Thank you.